What if I told you that the highest point in the continental United States and the lowest point in North America are only 85 miles apart? Not in two different states, not even in two different mountain ranges worth of distance. Both are in California, and the reason they sit so close together is one of the strangest stories in American geography. This is Mount Whitney. At 14,505 feet, it's the tallest peak in the lower 48 states. A jagged granite spire in the Sierra Nevada, capped in snow most of the year, popular with hikers who train for months just to attempt its summit. Now look at this. Badwater Basin in Death Valley, 282 feet below sea level. It's the lowest point in North America. Summer temperatures here have climbed past 130 degrees Fahrenheit, among the highest ever reliably recorded on Earth. Salt crystals crust the ground for miles in every direction. One point is snow, the other is salt and fire. And yet, in a straight line, they're separated by roughly 80 miles, a distance you could drive in under 2 hours. So the question is simple. How does a single state contain both extremes, sitting almost side by side? The answer isn't a coincidence. It's written into the rock itself.
To understand this, you have to go back around 20 million years to a slow, violent process still happening right now beneath your feet. This part of the American West sits inside something geologists call the Basin and Range province, a vast region where the Earth's crust isn't just sitting still. It's being pulled apart. As the crust stretches, it doesn't stretch evenly. It cracks along enormous faults, and entire blocks of rock tilt. One edge rising into a mountain range, the other dropping into a valley. Do that over and over across millions of years, and you get exactly what this region looks like from above. Parallel mountain ranges and dropped valleys again and again like a rumpled blanket. The Sierra Nevada, home to Mount Whitney, is one of these tilted blocks, lifted dramatically on its eastern edge. Death Valley is one of the dropped ones, sunk far enough that it now sits below sea level. They're not unrelated landmarks. They're two faces of the exact same geological process, born from the same stretching, cracking crust, just pushed in opposite directions. But there's a second mystery hiding inside Death Valley itself, one that puzzled scientists for decades. Out on a dry lakebed called Racetrack Playa, heavy rocks, some weighing hundreds of pounds, leave long trails carved into the cracked mud behind them. No footprints, no machinery. No one has ever seen one move. For years, this made international headlines as an unsolved phenomenon. The mystery is solved now, and the real explanation is almost as strange as any myth. In 2014, researchers using time-lapse cameras and GPS-tagged rocks recorded it happening. On cold winter nights, thin sheets of ice form across the playa after rare rainfall. When the sun rises and that ice begins to melt and break apart, light winds catch the floating ice panels, and they push the rocks trapped against them slowly across the slick mud, leaving trails that can last for years. No aliens, no magnetic anomaly, no hoax. Just wind, ice, and time in one of the driest, most extreme places on the continent. It's a fitting detail for a region defined by forces most of us never get to see happen. Zoom back out, and California's extremes make more sense as part of one connected system. The same tectonic forces that raised the Sierra Nevada and dropped Death Valley are still active today. This is one of the most geologically restless regions in North America. Regularly measured, monitored, and studied precisely because it never stops moving. It's also why the stretch of California draws scientists from around the world. Geologists studying active faults, climatologists measuring record heat, and hikers who, in the right season, could stand on the coldest snowpack in the state in the morning and reach some of the hottest ground on Earth by nightfall. So the real mystery was never how could this happen by chance. It's that it isn't chance at all. Mount Whitney and Badwater Basin are two ends of the same slow-motion event. A stretching, cracking piece of crust that's been rearranging this land for millions of years and is still doing it right now several millimeters at a time. Next time you look at a map and see California's coastline, its cities, its highways, remember that just beneath the surface, the ground is still quietly pulling itself apart, one fault line at a time. And somewhere in that process, 85 miles apart, sit the two most extreme points in the country. What other landscapes are you standing on without realizing what shaped them?